All right, so now we're going to talk about classifying the elements. We're going to break them up by the neighborhoods like we've done before. So we're going to talk about S block, and then we're going to talk about P block, and then we're going to talk about D block and F block, okay? So let's start with S block. So remember, S block is these two. Let me make sure I'm sorry. All right, so remember, S block is these two these two columns right here, all right? But we're not really going to include hydrogen because he's not a metal. But let's talk about what the names of these families are. So this very first family, this column right here, what's the name of this family?
Metalloids?
Nope, that's a classification, but not the name of the family.
Oh.
Alkaline metals.
Alkali metals, excellent. Alkali metals. So that's group 1 is the alkali metals. And it is in group 1. So how many valence electrons do you think it has? Oh, never mind. I already said the answer. It has 1 valence electron. All right. So the group 1 metals, they're not the metals we typically think of. It's like calcium. It's what we think of as like vitamins or like nutrients. Calcium and potassium and sodium and lithium and all that stuff, okay? But they are metals, but they are, what's weird about them is they're super soft, okay? Like you can cut them with a knife, and they have a low melting point. They are highly reactive, and they are never found in nature pure. In other words, they're never like, you're never just gonna walk out and be like, oh, look, there's a chunk of sodium, let me pick it up. Or a piece of calcium, let me pick it up, okay? They are the most metallic of the elements, and that just means in terms of their properties. They're not the most metallic in terms of what we think about, but in terms of how they actually define like a metal, okay? So I want to show you guys a quick video clip. I wish you guys could be here. I would love, the school won't let me do it anyway, but I would love to buy a chunk of sodium and show you guys what it does, okay? So like sodium, what happens is the reactivity increases as you go further down. So reactive means like, in this case, they cannot even be exposed to the atmosphere, okay? If you have a piece of sodium, if I were to go try to buy a piece of sodium offline, which is not easy to do, okay? But if you were trying to go buy a piece of sodium or potassium or rubidium offline, if they were to send it to you, it is soaked in oil and sealed, because if it is exposed to the air, it will explode, okay? It's kind of cool. All right, so let me show you a quick video. And we talked about them being soft. You can actually cut them with a butter knife, okay? You don't have to write this down. I'm just telling you how soft it is. It's soft enough that you can cut it with a butter knife. All right, so let me show you a quick video. I'm going to share my screen. One second. And show you a quick video about just how soft they are and how explosive they are.
Miss Payne,
Yes.
are you gonna post this recording on Schoology?
Somebody talking to me, or they just forgot they're not muted?
Ma'am?
Oh, I just heard somebody talking. I didn't know if someone was asking me a question or not.
Oh, sorry. I was asking if this recording is gonna get posted on Schoology.
Yes, I will post it on Schoology.
Okay, thank you.
Okay. So give me 1 second. Let me mute here. Unmute here. You guys should be able to hear me now. Can you hear me? Yes.
Yes.
Okay, good. All right, you can still look up there, Kate. Thank you. All right, share screen. Yes. All right, so this is just going to show you just a small snippet
of how easy it is to cut.
Alkali metals are soft, silvery white metals that are good conductors of heat and electricity.
So I want you to see, he was cutting that. If you look at his knife, it's not like some giant butcher knife or anything. And you can see that all of these, this is potassium, this is sodium. Okay, so again, it's sodium, not sodium chloride, which is what we put on our food, but you can see it oxidizes. And what I mean by oxidize is just like, you know how rust forms on metal? So this is kind of like a form of rust. So you can see how it's nice and dark right here. And then as soon as he cuts it, where it's not exposed to the air, it's super shiny and silvery. But you can again see that this knife is just...
Alkali metals are soft, silvery white metals that are good conductors of heat and electricity.
He is not putting a lot of effort into cutting that, okay? So that's one. They're super soft, they're silvery, but once they get exposed to air, they kind of oxidize. And then once they get exposed to moisture, all right, let me show you what happens here. All right, so this is a chunk of, notice that he has on gloves, one. All right, notice it came in this steel package. I want you to notice how big this piece of sodium is as well.
Vlog it out. I'm recording it. And
Your study wants to throw it in.
oh, Trevor.
I do.
I will.
Here, give me the glove.
All right, I'm gonna just keep throwing it.
Oh,
I
explosion!
need a slow motion. Hold on.
Wait,
Hold on.
wait.
We are recording.
Wait.
All right, speed up a little bit.
That's fine.
All right, so he has the sodium in his hand. He's gonna get ready to chunk it in the lake.
That way?
A little bit of smoke,
Oh no.
flame. That kid was really excited. All right, so you can see again, you see a little bit of smoke. So it's coated in oil. I know you can't tell, but it's coated in oil. It does not take long to react at all. First, it starts out smoking. Then you see the flame, which is the same color flame from our flame test. Okay, so sodium will actually burn purple. I mean, potassium will burn purple. All right, so those metals are highly, highly, highly reactive, okay? I cannot emphasize enough how reactive they are, okay? All right, so let me now go back to the notes. Share screen. Yes. All right, so we had group one was the alkali metals. They had one valence electron. They were soft, silvery. And let me change my, let me mute this 1 second. All right, sorry. Okay, so now group one, alkali metals, one valence electron, soft, silvery metals, low density, low melting point, very, very, very reactive, never found purely in nature, and they are the most metallic of all the elements. Group two, can somebody tell me the name of group two? The name of group two. Thank you, Kay. Kay said the alkaline earth metals. Very nice. And then how many valence electrons? Somebody can tell me that.
Two.
Thank you. 2 valence electrons. It's in group 2. All right. These are more dense and stronger and harder than group 1, okay? But less dense, less reactive than group 1, okay? So they're less reactive. So they're still very reactive, but not quite as reactive as group 1, okay? But as you move this way on the periodic table, any metals that you experience are gonna get denser and harder as you go to the right, okay? So they get denser and harder.
the metals. This is if we're talking about metals. As you go this way on the periodic table, okay? So the softest ones are going to be in group 1, then group 2 is going to be a little bit harder, and then group like D block, like the metals that we're used to, like copper and gold and silver and iron, they're going to be even harder than the other ones, okay, and denser. All right, so now that covers S block. S block, that's those first 2 columns on the periodic table. P block, this is all the way on the other side of the periodic table. So if we, like if I were to draw the periodic table, blah, 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 come back up. All right, so now we're dealing with P block over here. All right, P block is groups 13 through 18. The properties are kind of all over the place because if you really think about it, our staircase runs right through P block, okay? So you really got a mixture of metals and non-metals and metalloids. You got solids, you got liquids, you got gases, you got everything over there, okay? The metals that are there are, remember I said they get harder and denser as you go that way. So they're going to be harder than the S blocks, but they are softer and less dense than D block, okay? Because D block is like your quintessential metal, like again, like I said, like copper and gold and nickel and platinum and silver and all that stuff and zinc, okay? So this is group 13 through 18 for P block. All right, your metalloids, the ones that are solids, they're going to be very brittle, which means they are very easily broken apart, okay? But they do have metallic and non-metallic properties, okay? Metallic and non-metallic properties. All right, any questions so far? Okay. Give you a second just in case you're still writing. And then I will scroll up. We're going to move on to G block. Well, we got to finish P block first. Sorry. All right. So now, continue on with P block. Remember, you got a whole bunch of stuff going on over there. So you have your metals, you have metalloids. You also have non-metals over there, okay? So your non-metals, group 17. So let me show you group 17 again. Tell me if you remember the name of group 17. This is group 17. 17 is this group right here. Anybody remember the name of this family? Starts with an H.
Halogens.
Halogens, thank you very much. All right, that is group. And how many valence electrons would this one have?
17.
Not close. So you never have more than 8. So just subtract 10.
Oh, 7.
Yes, exactly. Okay. So this group, all right, the halogens here. Halogens, group 17. Remember, this is one of those family names that you do need to know. Okay. So this is the halogens. They have 7 valence electrons. They are the most reactive of the non-metals. Okay. So your most reactive, you have two very reactive families. Okay. If you're talking about metals, it's the alkali. If you're talking about non-metals, it's the halogens, okay? And I'm going to explain to you in a second what makes them so reactive, all right? Group 18, that's that group of big gases, all right? So these guys on the very far end, okay, right here. Anybody know what that group is called? All those gases in red. Anybody remember group 18, all the gases?
Noble gases.
Yes, thank you very much. They are the noble gases. All right, so let's go back to our notes here. All right, group 18 is the noble gases. How many valence electrons? It's group 18.
8.
Very nice. 8. All right. They are generally non-reactive or unreactive, however you want to say it. Non-reactive, unreactive. In other words, they don't like to be bothered. They're not going to combine with anybody to make compounds. They're just chilling. They are, this is the it group, okay? This is the it group. And I'm going to tell you why in just a second, all right? They are also called inert gases because inert just means that they do not react. Okay. All right. Let's talk about just for a second reactivity. Okay. The reason why group 18 is the it group is because they have, specifically because they have 8 valence electrons. 8 valence electrons. Oh, wait, 8 valence energy levels. This should say electrons, but that's okay. All right, 8 valence electrons. Everybody wants 8 valence electrons, okay? Because if you have 8 valence electrons, if you have 8 valence electrons, you have a full outer ring, okay? It's just like when I get hangry. If I want to be happy, please feed me, and I want to be full, and then I'll be a little bit happier, okay? So remember when we were doing Bohr diagrams or when we were doing electron configuration, every time we got to the noble gases, then we would start all the way back over. And when you started back over, you got a new ring, okay? So that means when we're looking at these noble gases here, every single one of these, like if you get to the end, he has like sodium, not sodium, neon has a full ring. After that, we have to add on another ring. That's when you get 3 rings, okay? Then we put all of our electrons on there. We get the argon. He has a full ring. Now we have to add a new ring. Everybody wants to be full, okay? So here is why the alkali, which is this group, and the halogens are the most reactive. Alkali metals are like, oh my gosh, I got this one extra electron. That's why I got a new ring. If I could just get rid of this electron, I will look just like a noble gas. So they do everything in their power to get rid of an electron, okay? And this is going to be important when we get into naming, okay? Now, over here, these guys are like, if I had just one more electron, then I would have a full ring. I would look like a noble gas. So that's why a lot of times you get a match made in heaven between these guys, okay, when we start talking about bonding, because this guy's going, hey, I don't even want this electron. Let's hook up. You can have my electron, and then we can both feel like a noble gas, okay? All right, so now that's what makes them so reactive, because they are so close to looking like a noble gas, okay? All right, so that's why the noble gases also are the it group, because they are already happy with what they got. All right, so that's P group. Now let's go on to D block. D block is pretty easy. That's groups D through 12, okay? We had a name for them. Trans means change. These are the transition metals. And the reason why they're called transition metals is because their valence electrons change. Because remember, when we get to D block, we drop down a level. So it's like, well, maybe they have some electrons. I don't know how many electrons they have on that 4th ring, because they have a 4th ring, but those other electrons drop down to the 3rd ring. These are the metals that we think of with typical metallic properties. So again, this is like your silver and your gold and your copper and your iron and your zinc and your platinum, just metals that we're used to hearing. Okay, so this is, all those metals are located in D block. Okay, that's it. You don't have to worry about blank number 4. If you need it just because you're kind of you're kind of OCD and you're just like, I want to know what it is, the first blank is S, and then the second blank is D. Okay, if you just need it, all right? But we don't have to talk about it. All right, so the last thing we need to talk about is F block, okay? The first row is known as the lanthanides. The second row is known as the actinides. And if you were to look at a periodic table, so let me switch for a second. All right, if you were to look at the periodic table, this element right here is lanthanum, and this one is actinum. And that's why we call it the lanthanide series and the actinide series. All right, so remember we talked about the colors representing different things. Look at all of these clear boxes, okay? All these clear boxes. What that means is, okay, a couple of things. One, most of them are man-made, okay? And they also tend to be very radioactive. So remember I told you those clear ones mean that they are man-made. So right here. Okay. All right. Lanthanides are very shiny and they have reactivity similar to the transition metals, which is D block. All right. All right, I'm going to leave this here for just a second. Make sure you got everything down. And then we're going to do some reviewing, okay? And how we're going to review is, I'll just tell you, we're going to do something where I'm going to ask you questions and you're going to answer on your computer or on your phone, but only I can see the answers. So do not feel any kind of way about if you get it right or wrong. Look at that. I didn't even touch the screen. You saw that? It just jumped. I didn't even, okay. I don't even know how. When is summer? I don't even know how that got over there. Oh, there it goes. Okay. All right. Quick review before we start. Okay. Remember that the colors of the periodic table tell you your state of matter, solid, liquid, gas. All right, and then remember that whether you are on the left or right side of the staircase tells you whether you're a metal or non-metal. Where are the metalloids? Anybody remember what the metalloids are?
Aren't they along the zigzag?
Yes, they are actually on the zigzag. All right, so I am going to now, let me go ahead and stop this recording, and then we are going to do some practice.